And I am live. That is cool. And today is 21st of August 2025, Thursday. And in today's stream, we are going to do graph questions from CSES because from now on, it is very good instead of keep solving blindly solving questions if we just practice on specific areas specifically. For now, it is graph, and then it is going to be DP dynamic programming questions also on the CSES website. And I also need to work on probability. I do not know anything about probability. I have to work on probabilities. So yeah, this is a good format. We can just select a topic, solve some questions, a bunch of questions on that specific topic, maybe enough so that we are not flabbergasted every time we see that topic. So this is cool. And today we are going to start with graphs. And I am audible and screen is also visible. That is cool. Now, CSES graph questions. And the theory that I read about graphs is, of course, from this book. This book is amazing. As an index from this book, you can see everything. At least you can get the names of topics which are necessary in competitive programming, like graph algorithms. Till now, I have only read these two chapters, and they are pretty good. From this chapter, from this part specifically, graph representation, I saw that we can use adjacency list representation. And since I hadn't read any theory on graph, this was the way I was representing graph in data for every question that I saw till this point, and it was just a coincidence that I came up with the same way that is described in this book. And so there is this way you can represent graphs adjacency list, in which at index I you have a vector which contains indexes of all the nodes which are connected to this I index, to this I node. So that is cool. That is one representation. Then there is adjacency matrix, and you have the number of nodes. You have a matrix, and if there is a connection between 2 and 1, there should be a 1 here. And yeah, just that. And also if it is directed, then also the order of ones and zeros depends. And also if this is weighted, then you can replace ones and zeros with the weights of the edges, like this. And then there is edge list, and this is also cool. When you have points on a number line, then you can treat each point as a node, and you can store ranges. When you have ranges on a number line, you can store them here and sort them accordingly. So that is cool. And then there is how you can do DFS. DFS is cooler, like simpler to implement. Implementation is simpler for DFS. Then there is BFS, which is a bit more complicated. It uses queues, and yeah, implementation, a while loop with queues. And then there are applications finding the shortest path using DFS. Now, we are going to move on and we will do some graph questions. I have done a few graph questions for now. We are going to do more. So that is cool. Nope, I am not on code shift. I only do, I till this point I have done what is this? Code forces, like, and lead code questions from neat code and advent of code. That is cool. And now CSES. Okay, so and with these questions, the thing is not to solve them fastest, quickly as possible, but to practice and get to know these things. And I have created a Tmux session to do that. Graphs. There is some update in Vim. There are always updates for plugins. graphs, and yep, we are in new. There are n pupils in Oilov's class and m friendships between them. Your task is to divide the pupils into two teams in such a way that no two pupils in a team are friends. You can freely choose the size of the teams. No two bipartite graph. That is a bipartite graph, and I can use BFS. This was actually suggested by someone in the comments. This was, yeah, in one of the live chats, that to find a BFS, to find a bipartite graph, you can use BFS, and every time you change a layer, every time that you change a layer, you just increase the layer by one. You just do that. You know that you are alternating between groups. First, you take a node, and the next layers would be in the other group of the bipartite graph, and the next layer would be in the starting group, and they will alternate. So that is cool. Input NM, the number of pupils and friendships, N pupils and M friendships. Then there are M lines describing, and in this we can use adjacency list to store them. Yes, that would be nice. And print impossible if there is no bipartite graph possible. Okay, and print in, okay, for makes sense. Makes sense. Okay, I can do 0, 1, and the limitations N and M, A and B. Hey, cool. And since there are no test cases, um, and a vector vi or graph n, and I less than m I plus plus. And right, I have my graph, and now BFS, but I need a few things for the BFS, for which I can use some clever thing. Bool visited. Since I do not know the size of this visited, I can reassign that here. Assign size n, n plus 1, and false. And I would also need another vector, bool group, and do the same thing with that. Right, and okay, bool, and then I do not have to write another function. I can create a queue right here, and queue size n plus 1. Queue does not have a size, and queue dot, right, I have to see the first number that, or any number that has any node that has a connection. So int connect connect equals L. So I know that L has at least one connection, and I can push L to the queue. Push L to the queue, and Now I have stuff in my queue. I can do visited L L equals true, and also group of L is true. And now while not q dot empty, we can get the first thing, int c, which is like current, equals q dot top. Okay, there is front, yeah, front, and q dot pop. Now I have the first thing, and yes, and it is going to be visited. Then I need to add everything for this. Okay, int x in graph c if not visited x. If x is not visited, then visited x equals true, and group of x equals not group of c opposite, because it is in the next layer, right? How would I know that a bipartite graph is not possible? Shit, how would I know if a bipartite graph is not possible? Yeah, that is a bit tricky, maybe. If I have nodes like this, this is a bipartite graph, that is cool. But if it is like this, then it is not. And if I start from here, I will see at the second layer I have this, and then in the next layer I have this, and I should not have these. So I should not be visiting something that I have already visited. Or maybe instead of this group, I should use, instead of making this group like this, I can make this an integer. Integer or char would be better. Char character, and initially everything is 0. 0 means that no group, and when I'm assigning a group, it would be either 1 or 2. 1 initially. We are at group 1, and okay, right. And group would be, okay, this is bad. Uh, Not a literal one. A one like this would be better. And I can here use something cool like this, and group L, group C current equals 1. If this is true, I will get 2, and if this is false, that is group C is 2, I will get 1. That is cool. Anyways, if I visit some visited node and its group, if I have visited, then Cool. Okay. If I have visited this node before, then if group X equals group C, then we are messed up. And then bool P, we will suppose it is true, but then P equals false. I don't even need this. I can return the function simply. Impossible. Impossible and return. Return the main function, right? Return 0, else just keep on going. And if I do not return at the end, I should have what I was looking for which for int I equals 1, I less than equal to n, I plus plus, cout, um, cout group I and space or new line depending on I equals n. If I is the last character, then output n. That is completely wrong. Okay, this 1, 2 is correct, but shit, this makes sense. Shit. Okay, that makes sense. I have different components. Okay, this thing just went through one component. Okay, that makes sense. Now what I can do is I can start iterating through all the things. Uh, right, makes sense. This group and the other thing are going to be global. And nope, not even this visited. Q is also global, like global in the sense. And okay, and now I will iterate through everything. I less than equal to n I plus plus, and if graph I dot, if something is connected to this node and not visited I, this node has not been visited. If that is the case, then we can int L or I. We can replace this with I, right? And everything else is kind of cool. Okay. Okay. Group I equals 1. Okay. If this is a new component which I am visiting for the first time, I can put it in any group, does not matter, right? And graph I size, and if not visited I, then push back I, and visited I equals true, and put it into group 1 and run the complete graph thing, BFS. Okay, let's see. That is cool, because the mistake was that there were components. And now, yes, in this, when you want to submit, you have to upload a file, like submit, and you have to upload a file. Choose file. Do not pay attention there. Shit. Programming competitive programming. CSES graphs, and this one is, which one is this? Building teams. Submit. And that, okay, shit. I submitted in C++11, which might be bad. No, 11 is, yeah, runtime error. 11 is bad. I submitted in C++11, which is bad. Shit, I didn't even submit anything. How is it submitting the same thing again? Shit. Building teams. How do I change the version? Building teams. C++20 and runtime error. There was a runtime error. It runs completely fine here. So let's see. CSES and runtime error. Shit. Okay, what is the runtime error? Empty. There should be some message from the compiler about what the error is. I'm getting a runtime error, which does not make sense. Runtime error. Runtime error. Visited n+1. Okay, that might have been the thing. I'm taking in N, then L and R till I am right. Right. Cool. Okay, hopefully. Okay, wrong answer is better. At least we are not getting a runtime error. Okay, if this is the case, I'm getting the wrong answer at times. Right. Why is this wrong? This is wrong. Okay. There are 10 things and 20 connections. 7 to 10. So 7, 3, 7, all of them should not be in the same group. Seems like they are. Grand building teams dot flash out. Again, is that completely wrong? 1, 2, and that seems right. 1, 2, and 3. 1 is connected to 7. 4 and 7 should not be in the same group, and they are in the same group, so that is wrong. Why would my program do something like this? I start with 1 equals 1. All right. And if graph.size and visited x equals true. If not visited x, then put it equal to true. Um, in C equals Q front push I 1 till n is 10, graph.size visited, if not visited I, then push back I into Q and D start the whole DFS thing, BFS thing, while Q is not empty. And when Q does become empty, exit and go find this thing which is not visited. um, q dot pushback I. Or I can apply df. Okay, I do not exactly know where the layer is. No, I do know where the layer is. I am currently at some level of the layer, right? And I am putting them like this. If current layer is 1, then this thing will be 1, and I will get 2. But if current layer is 0, I will get 1. If visited equals true, then check if they are the if visited true, then check if they are the same. Okay, so something is clearly wrong. Yo, hello. I want to do competitive programming at your level, for high level, and I am a fresher this year. Can you please give me any keys? Hello. How can I connect to you? Can you tell your LinkedIn profile? Mine is Joshi. Please. Um, I there is a Discord thing in the description. You can join Discord if you want. And as a beginner, the best thing you can do, or anyone can do, as a beginner programmer is CS50. This is one of the best things, which is not loading. Yeah, CS50. Do this. This is one of the best things. This is what I did, and everyone should do if they want to become a good programmer. This is pretty cool. And shit. Okay. I cannot even see why this is wrong, but I would like to. So let's actually draw this thing in Excalibur. Draw this whole thing. Or maybe before going through the example and finding out why this program is wrong, we can diagnose this program and see what could be wrong here. So this part is like this part is classic, this part is theory. We take in n and m, then we create a vector of size n plus 1, number of nodes plus 1, then L and R, take in L and R, run this loop m times because there are m connections. Then graph dot push back left and right into left and right, push back left and right to each other's adjacency list. Then Boolean to represent which things have been visited, and group a vector of characters which would represent the group, right? Which would represent the group, and then Q, which will be the queue, which will act as the queue. And then we start with node number 1 with index number 1. And if something is connected to our node number I, that is, if its size is some integer, non-zero integer, and if this one has not been visited, then call the BFS algorithm in this, add this to the queue and put visited I. Yep, put visited I equals true and put this in group number 1, and while queue is not empty. Shit, this is so retard. Shit. After this, you have to do q dot push x. This is literally so retard. Shit. That was shit. That was very stupid. That is very stupid. Very stupid. Now the answer is correct. Shit. That was very stupid. Shit. That was very stupid. Eh. How did I even got three correct with that? So the thing that I was doing wrong is we have a queue which has all the nodes which we have to go to next. But when I was traversing through all the nodes which are connected to the current node, I put its visited equals to true and also the group that this node should go to, but I was not doing this. I was not putting this current node onto the queue so that it will be processed next. Shit. That is very stupid. Shit. That was very bad. Okay. There is still something wrong. Okay, let's go through the code once more. If not, okay. Here, while not empty, get the current node that we are at the front of the queue, pop it, and then traverse through all the edges that are connected to it. And if they are not connected, if they have not been visited, then put visited equals to true and check the group, right? Put the group that this node should go to, and then push back this node onto the queue. And then else, if I have visited this node earlier, then check if the group of this node that I am at and the group of the node that whose adjacent nodes I am traversing through, if it is the same, then print out impossible. OSSIBLE, impossible. Okay, why are there spaces? Makes sense. This makes so much sense. There are spaces because there are going to be nodes which have not been connected to anything. There are going to be nodes which do not have any connections. Therefore, I can put those nodes to any group and does not matter. It can be one or two. So vector group for them, let's say by default group is one. Yeah, this is, and this should not even break because the only time that I'm checking the group of some other node is this time when it already has been visited. So that is fine. I'm even outputting possible. Yep, impossible. So that is cool. And submit. Okay, shit. This, let's see. Accepted. That is fine, but this took a lot of time. And now we can go to analysis and read the actual thing. Now, in this problem, we are asked to check whether a graph is bipartite. The key observation is to solve the problem. Is that if we assign pupil X to team 1, then we have to assign every friend of X to team 2. Yes, makes sense. We can continue this process to the friends of the friends and so on. If we notice that the two friends have been assigned to the same team, we know that the division into two teams is impossible. Otherwise, we found a valid division for all pupils reachable from X. We start by going through all pupils. If pupil X hasn't been assigned to a team, we run a DFS. Yeah, DFS, we can do DFS. Assign X to team 1 and all reachable pupils according to the graph structure. After this, we go through the pupils and print the team assignments. The time complexity is this. Okay, they have implemented DFS and let me also implement DFS. I did this right now with BFS, but now I would like to do this in DFS, which is cool. That is what we do, practice. Now when we get the input, Right here, we can reassign visited dot assign n+1, resize this thing, and default would be false, and group dot assign n+1, and the default team is 1. And q does not matter. And then if I see this thing is connected and it has been visited, if it hasn't been visited, then I will call the DFS algorithm, which I can call here DFS with I. Okay, DFS will take I and anything else. Yep, it will also take graph I and vector int, not vector or vector graphs, and here, and this is bad, you should use a reference here. We should use a reference here because we do not want to copy and pass big data structures. Now for this, we will first check if this thing is visited. If visited I, then return, else visited I equals nothing. We do not need that. What we do need is for int I equals 0, for int x in graph I, if not visited x, if x hasn't been visited, then x, put x into some group of x equals 1 2, group I equals 2. Yeah, the second one, yeah, if group I equals 1, this will be 0, so that is wrong. If group I is 1, I will get 1 true, and 2 will be passed on to group X, and if group I is 2, I will get false, and I will get 1 into this thing, into group X. Visited X equals true, and DFS X with graph. Else, if it has been visited before, I would like to see its group. Let's say it returns bool. If visited I, visited, then check, what check? I cannot check anything. If visited, then out. I do not know from where this thing came, so yep, I can assign a group here. Visited I equals true, and group I equals 1. Yep, and group I equals 1, and visited I equals true, and do this. Okay, and here, right, so I will always have something, and for the friend, I will check if group for X equals group I, then return false. At the end, return true if everything went all right, and here if not, DFS return false. And here If not DFS I, and for this graph, then break, not simply break, bool possible equals true, and here possible equals false, and break. Now if P, if possible, then do all of this, else see out possible, impossible, see out impossible. Let's see DFS. Okay, and now testing time. And today is also a contest. It is going to be fun. Let's see what happens in today's contest. Shit. It would be really nice if I could reach a specialist in today's contest. I only have a little rating remaining. I guess less than 40 points. I need less than 40 rating points to reach specialist, and it would be nice. It would be nice. It would be nice. Today is Division 3. It would be nice. Shit. I am already scared. Okay. And submit again. C++, choose file, which is building teams, C++ 20, and okay. Did I leave anything? Nope. Yeah, that is cool. And now we will go through the analysis and see if there is something interesting that we could copy, something interesting that we could incorporate in our own problem solving things. So we read whole the this whole thing, and now okay, include normal stuff and then constant. Okay, they are using standard array here, array of integers on the stack, but I mean it is their choice. But Björn Stroustrup, the creator of C++ language, he said whenever possible always use vectors to store things. Do not go after like built-in C stuff. Using a vector is always the best thing, and you should have a very strong reason when you are not using a vector and going after something else. So yeah, but they can use, like they created this amazing website, so that is cool. The return value indicates whether team assignment was okay. That is what we did. Return value. Okay, they take int x and a team. Okay, and they have graph right here. Okay, if teams x is not equal to 0, if teams of x, this current thing, is not equal to 0, that is if it hasn't been assigned, then put x equal to this team and return. Otherwise, if x has been assigned to a team, then teams x equal to team. Okay, if x has been assigned to some team, then check is x equal to the team that it should be assigned to, and if that is, then return true. Otherwise, assign this team to x and then go through everything. And if not, DFS and 3 minus the team. 1 2 makes sense. This is the same thing, and this is the same thing. This is the same thing as this thing. We can also replace this and do the same thing that they are doing there. We can do 3 minus group I, because if group I is 1, this thing 3 minus 1 would be 2, and if group I is 2, 3 minus 2 would be 1. It would still run. There is something wrong. makes sense because this is not an integer. We are using here characters, right? So this thing is the thing we have to go with because we are using characters and not strings. Yeah. So we cannot use this because we are not storing teams as integers. We are storing teams as characters, and 0 and 1 are not characters, character values. And take in everything and start iterating. If not 0, then continue. Otherwise, call DFS. Right. Right. Cool. Otherwise, this thing. Now the next question. Round trip. You would see this is the one. Byte land. Cool. Byte land has n cities and m roads between them. Your task is to create 5 and 112 MBs we can use. That is cool. Your task is to design a round trip that begins in a city, goes through two or more cities, and finally returns to the starting city. Every intermediate city on the route has to be distinct. Okay, okay. So I need to find a cycle. I that is easy. That is easy. I can use BFS. I can use DFS. The first input line has N and M. M is the number of connections. There are M lines describing this, the road between two cities at most. Okay. Print first, and if there is no solution, then impossible. Okay, that is cool. I just have to apply BFS. DFS or BFS does not matter. And N, M, CNN, M, and now graph vector vi graph and visit or vector bool visited and uh, no, I would not need a cube. Yeah, this should be enough. This should be enough. I only need to detect that, but if there is a cycle possible, uh, then I would like to see the path. The path. Yeah. And when I know the sizes, I can assign them again. Graph dot assign n plus 1. I don't have to do this to graph vector vi graph size n plus 1 vi, right, cool. And then visited or assign size n plus 1, and initially everything is false, which I do not have to say, it will be false. Path dot, I do have to say false here because that is how things work when you are reassigning stuff. AWSIGN, and then for int I equals 0, I less than m, I plus plus, and int L R, cin L R, and graph L dot pushback R, and graph R dot pushback L. I have my adjacency matrix now. For int I equals 0, I less than n, I plus plus. If not visited I, then call the DFS function, and d it will return void DFS int I and vector vi reference called graph. That is what it will take, and here we are going to call that DFS I with graph passing in as a reference And if there is no cycle at the end, okay, start equals -1, and if there is a cycle ever, now if there is a cycle, okay, if int dfs int s equals dfs for it with I graph, and if s isn't equal to -1, then start equals s and break through the whole thing, and if start isn't equal to -1, then see out the whole thing. Else see out and possible. Okay, and now the implementation for the DFS, which is going to be if visited I, which I do not want to do. I can do this right here before calling visited I equals true, so that if I'm calling DFS on some particular node, it is already true. And for the path thing, path I equals I, and right, I do not have to check for visited. I can just start loop for int x in graph I if visited I, if visited x, then we are cool. We can return in. Okay, but how did I got to x? Then I did some moving throughout and I got to x again. Okay, how would I know the path then? The whole path. That makes sense. So I need to return a pair so that I know the current I and the current x, and the hope is there was one branch that went forward and then there was another branch which connected, so I need the common point at which both the branches were meeting. Yep, I need the common point at which both the branches were meeting, so that I know this, I know this, and I know that these two are being connected. I can go back from both of these things and I will find a common point and I can print this whole circle. Makes sense. So instead of this, pair of integers, and okay, if visited, and then return I comma x, and if not visited, visited x equals true, and path of x would be equal to how I got there, I. And if I do this for everything and I do not find anything, then -1, and shit. I'm again getting this line on the left, which I shouldn't be getting. Wait, why is this correct? Because this is wrong. Now it is cool. Instead of int, if s dot first isn't equal to 1, then -1, or I don't even need this. Okay, makes sense. Makes sense. It is auto, right? My compiler doesn't know what to do with auto. Okay, start equals s and break. Now, if it's start dot first equals not equals -1, then no solution. But if it is equals to minus, if it is not equal to -1, then we have ourselves a solution. And at least let's, okay, let's not try to print it and check if we are correct till this point. I would like to go throughout and print the correct solution. But now how do I find that common point? Now what I have is, let's say I have a chain of nodes connected like this, and I have two chains actually, this thing, right? And I know the address of this thing. I know the address of this thing. I can go back, 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 back. I know from where I got to this node, and for from where I got to this one, from where, and yep, go back and do the same thing here. And I need to find the thing that is common in both. And I also know that these two are connected directly. And if I can do that, I have the whole thing. So to do this, I think I can store all of, as I'm moving up this chain of sequence, I can keep adding all of these into a set till I reach the root, because I do not know how long do I have to go. And I can keep doing the same with this, not till I reach the root. That would be bad, reaching the root, because let's say then before this, there are few things like how would I know that I need to stop these things? I would know because I would know the address of this thing. I can traverse back through this thing, get till here, and keep adding all of this into a vector, and also traverse back through this thing, get till here, and then print this whole thing starting from here till here, and then print this thing again. That is cool, but feels like I'm doing too much for something very simple. Just to remove these extra nodes, which I do not know if they are in the current sequence or not. This is about finding a cycle in our graph. So what else I can do? What I can do is I can store it in a vector, but then looking up would be very hard. So storing it in a set and going up till no till root would be fine. And then I can keep storing all of these nodes in a vector, and I will keep checking side by side if they are in this thing. And whenever I see a match, I have at least all of these things. And then all I have to do is add all of these things. And since I can only start from here, I will go from here, back, back. And when I reach the thing, I can print that. And since I have all of this already stored, I can print that, and I'll print this starting thing again. Okay, cool. Now what? Okay, right. So, right, end auto uh, left, right, let's say, equals start. And now while path left isn't equal to left, I also have to, spelling of path is wrong. create a set of integers, left path, let's call it, and while this is the thing, left path dot insert that makes sense. Right, insert left. Do I need left? I would need, yeah, adding left is fine, and then left equals path of left. And at the end, when I am at the root, I can do the same thing. Left path dot insert left. When I am outside, do the same thing. And now I would like to do create a vector vi right path, right path, and y path right isn't equal to right, while right, while left path dot count of left equal 0. While that is the case, I will add this current thing, right path dot push back right, push back right, and right equals path of right. Okay, after that is done, right path equals right. Now I just keep moving forward, keep moving backward, up and upwards towards the node, and at some point, left dot count, left would have the current. That is wrong. Would have the current right, and when that happens, whatever right I land on is going to be the correct right. Right, and int o right is right, original right. Now I have the original right and the thing that is common, which is equal to left, and all I need to do is keep moving backward from this thing and print this, and when I am here I can start printing this array from the start, from the end till here. Okay, or maybe I don't even have to do this while I was doing this thing. Would I need some size? I think I would need some size. Yep, I do need some size. So I need to store the whole thing in some response vi response, and let's dot push back left right, and here also let's dot push back left. I have everything till the common point. Now I need these things, and when I'm here writing, right is pointing to the common thing, and initially it is here, so I need to reverse and extend the rest dot. Can I do extend? How do I extend? Capacity, C begin, C end, clear, begin data, emplace, emplace would be nice. I think emplace might work, or emplace back, or emplace. or maybe simple pushback. If I give it, if I give it right path dot r begin and right path dot r end. Yeah, no matching function. Okay, makes sense. How to extend a C++ vector with a range with from iterator. How to do that? Insert vector of type t, insert this position at this. Okay, I can just give it end. How do I add to the end? To add to the end, I just give insert it begin +1 end minus minus. Yeah, minus minus end. So let's dot insert minus minus. Let's dot end and begin with right path dot r begin and right path dot r end. Okay, that does not give me any error. And what do I expect to see there? I expect to see this thing attached, being attached there. Okay, now I think cout less dot size +1 and for int I equals 0, I less than less dot size I plus plus cout res I space, and after that cout res 0, or it might just keep running and never end. Okay, while count equals 0, I am going back, right? The hope is that this thing doesn't start dot first space start dot end, right, second. Clang. What is the question's name? Question's name is shit. Okay. Round trip. I thought my Tmux stopped working, which is a horrible thing. This is the input. Copy and paste and nothing. That is crazy. That is okay. Something is wrong with my DFS. Something is wrong with my DFS. DFS I auto, right? DFS I. Is there a self loop? If visited, if not visited I, then we put if visited equals to true and path I equals I. Right, path I equals I, and then call DFS on I. Right, and inside DFS, if visited, then this. And what the heck even is this DFS? If visited, return this, and else call DFS maybe. Else DFS X. DFS X with graph. Copy this, paste, and nothing. Okay, DFS doesn't stop. There is something as if visited, then return. If not visited, then visited I equals true, and path for x equals I because I got to that place from here. There is some loop that I am getting stuck in. But if visited x equals true, I would always return. Okay, makes sense. I am not returning. Okay, I need to check this DFS. Okay, if auto C equals DFS for x and graph. Now, if C dot first isn't equal to -1, then return C. Okay, wrong answer is much better than no answer. Okay, and that even does not make sense. 3, 1. Okay, because I was printing something. Yep. I printed 3, 1. That means 3 and 1 are connected, which is true. 3 and 1 are connected, but that is not how they are connected. That is wrong. Okay, let me see out. Path, and I do not have a function that I can use to print a vector, but now I do. Run this and path. That is a very horrible path. What is this? What is this? This is a horrible path. Am I not setting the path? Yes, set the path here and in the DFS function. Return x and I. X and I is cool. And then path x equals I. That is also cool. And this is 0, 1. 1 is connected to 1. That is correct. And 1 is also connected to 5 and to 3. It is connected to 5. But being connected to 3. Okay, I must have called the 1 thing and right from 1. Right, I went to 3 and I put this thing here. And I went to DFS inside 3 and there I saw 1. Okay, that is wrong. Okay, so I saw the same edge twice, which is wrong, and I shouldn't probably do. Okay, which is wrong, and I shouldn't do. If it is visited, if visited, and if visited, and yes, and path I isn't equal to x. That is, I didn't just come from this thing. I should see a 1 or a segmentation fault. Okay. If path I is not equal to x, only then do this. Okay, segmentation fault shouldn't be happening. I am doing n+1 everywhere. And then here, if start isn't equal to 1, right? And Also here, start with 1 and equal to 0. Now I have to do a lot of practice in here. Segmentation fault, and let's see. See out path after this lang /out, and shit, it is taking me this much time, a lot of time, to do a simple thing, a simple graph question. I saw a person who did 150 CSES questions in 12-hour stream, which is crazy. He did 150 questions in a single 12-hour stream. So that is cool. That is something. In a single stream, which was 12 hours long, he did he did 150 questions. 150 left, comma, right. Okay, I'm not even outputting path. I'm getting a segmentation fault even before getting to that part. If not visited, then go there. Put visited equals to true, and this call DFS, and the error that I'm getting is only after I do this thing. I'm doing something horribly wrong here. Path I. Path I. Alright. Path I. I is the thing that DFS is being called with. And path I isn't equal to X. That is, yes, that is correct. That is correct. Path I isn't equal to X. Return I, comma, X, and otherwise and out once again. Copy, paste. Okay, something is horribly wrong in this. I keep calling the same thing again and again. Okay, this has to be inside if. Okay, makes sense. Makes sense. Else and put all of this here. And now, if path I isn't equal to X, then return. Otherwise, if this one hasn't been visited, then go and visit. Let's see if that is correct and that is not correct. So certainly I am outputting the path at some point. And let's see if that is correct, and that is also not correct. Okay, I do 3 1 1 3. 3 3 is correct, but 1 1 is not correct. So I would like to see what the path is that I came up with. The path that I came up with is correct. Okay, this is cool. And what are the values that I returned? Start dot first space start dot second, and the thing is 5 and 1, and there is something that 5 and 1 both are connected to, which is 3. Okay, so right, which is cool, which is cool, which is cool. These are both connected to, or both of them are connected to the same thing. Both of them are connected to each other. So I need to find a common point between them, which is 3. So I have put there 5. Okay. Left here is 5 and right is 1. Original right is 1 and okay. Then set of integers left path. Initially empty makes sense. Empty is also fine. Initially empty is fine. And return result response is empty vector. Then I see if left is not equal to left, that is, this is not a root. I think this is the wrong condition to be checked here, or maybe not. No, because if I got to this thing, then I got here some doing something, right? And then keep going back. And in our particular case, this is not true, at least in the first place, because path left is 5, path 5 is 3, 3 is not equal to 5. Therefore, I insert part left path into left path. I insert left, which is 5, and then left equals 3, and then I also push back left after changing left. Okay, that was a mistake. Now we are cool. Now we are absolutely cool. Right, that is correct. Because I can go from 5 to 3 to 1 to 5 back. Right, back to 5. And is everything else cool? If first is not equal to -1, if I have a solution, keep going back when I see a common thing in the left path. I do this, right, and in the right. This should be cool. That should be cool. Submit, but no, shit. I want to make sure that I get this correct. Because in today's contest, if I submit a wrong question, a wrong solution, I will get penalty for 10 minutes. 10 minutes penalty is a very bad thing. You do not want to get a 10 minutes penalty. 10 minutes is a very long time. So instead, it would be much better if you could just take 5 minutes and make sure that your implementation is correct. So let's see. At least this part is correct, right? Because my DFS implementation seems to be correct, right? I have taken care of edge cases. My DFS implementation seems to be correct. And what were the mistakes that I was making? The mistake I was making was I was not considering if I get from node A to node B, and then since node B is also connected to node A, this would be considered a circular path, but that is wrong. This is not what we have, right? We cannot choose a circular path like this because we need at least 3 nodes. So before getting to this, I have to go to some other node and then go back to this one, starting one, at least 3. Right, and we are doing DFS for that. Call DFS with I. Vector graph has all the connections, adds an adjacency list, adjacency vector list. Then for everything that is connected to this current node, I check, is this visited before? And if it has been, did I go to the current node that I'm at? Did I came to this node from this one which has been visited? If that is not the case, then I went to this node from some other node and now I'm back here again. Therefore, these two are connected. I can return I and X. Else, if that is not the case, if I haven't visited this node, then put visited equals to true, and I got to this node from I, path I and current C. Get the result for this current DFS and check if it is not equal to -1. If it is not equal to -1, then I got a solution and I should return that solution. See, then if I went through all the nodes that are connected to this particular ith node and I didn't see any meaningful, any circular connections, acyclic graph, if there is no cycle in this current component of the graph, then return minus minus. And then way down we go here. So this part is correct. The DFS part, I am traversing through each node. If not visited, then put visited equal to true. And I got to this node from ith node because this is where I am starting from. And yep, auto S equals DFS. Yeah, get the solution. And if solution is not equal to -1, then we do have an answer. We can put start equal to S answer and break. And in that case, if we do have a solution, then we will see if it is not, if this thing is not equal to -1, and left refers to one part, one node, and right refers to the other node, and these two are connected and they are also connected at some other node, and I just need to find this particular path. Original right equals right, that is what we begin with. Then set of integers left path, which is going to be every node that is connected in this path till I reach the root node. That is wrong. Shit. That is horribly wrong. That is wrong because I am adding everything to the response. But I will at one point go past this node that is common in both, and I will go past it. So that is wrong. I need to remove all of these extra nodes. Right. Shit, I need to remove all of these extra nodes. So that is wrong. I should not do this. What I should do instead is I can create a response here. Okay, now I have a set till this point and left path. I have left path and I have everything in the left path. Cool. Then while left path dot count for right equals 0, that is whatever the current right node is, it is not in the left path, and if at any point it comes in the left path, I will exit. But while it is not a part of the left path, I can, instead of this dot pushback, keep adding all of this, all the nodes from this, except the one that is common. Except the one that is common, and keep going up the right path. And then red dot push back the one that is common, which is right. And now keep going back in the left node path, original. I'm very stupid. Shit. Shit. Left, because first we go left and only then we go right. And after this, my path consists all of these things, and I need to add all of this extra path, but not like this, but reverse it. Or I could reverse the response vector which I have currently. No, this is fine. This is actually fine because I have everything from here. Nope, this is not fine. This is not fine. Res left path v left path vector while left isn't equal to right and left equals left, that is original left, and while this is the case, left path b dot insert this, keep inserting, insert, keep adding all of these things, and I have a path from here till here, like, okay, I have this node, and I know I have location of these two nodes. I just need to construct a path like this, and I know that these two are connected. I know the location of this node now because I went through this whole thing and found the common thing, and I have a vector which has all of these nodes starting from this at the start at the 0th index and this as the last thing. So I can keep traversing from this like this and keep adding all of these things starting from here till here, and in my and then take the reverse of this thing and append that at the back of this node, which is cool. So left path dot insert left, and left equals path left, insert is nothing, push back and keep moving left, and then rest dot insert minus rest dot end what left path dot left path v dot r right begin, and left path v dot r end. That is also correct. Yep, that is correct. And then right at one side I have this thing, and at the other side I have this. Right, I output everything and then just output this thing. Cool. This should work. This should work now. Let's see. What is this question called? Round trip. Yep, C++ 20. Let's see if this thing works. Okay, that is actually cool. That shit that worked. That shit shit that is cool. Okay, and now the analysis for this thing. Our task is to find a cycle in an undirected graph. Find a cycle in an undirected graph. The following code uses a modified depth first search that maintains a path from starting node to the current node in the depth first search tree. When we visit a node we have visited before, we construct a cycle that includes that node. Yep. Consider a node X that is the first node in a cycle we visit during the search. Since there is a path from node X to itself through visited nodes, the depth first search tree will eventually contain node X twice. This allows us to construct a cycle. But okay, we go through all the nodes in the graph and start a search from every unvisited node. If we do not find a cycle, there is no cycle in the graph. Okay, makes sense. So how do we do? Take an n, we resize the graph. Okay, that is similar to the tricks that we use using assign thing. Okay, they are resizing the graph to this thing, and then taken, create the graph adjacency list, and then visited, also resize the visited thing, and then if not visited, then cycle search. Okay, cycle search handles everything and also returns the function. Okay, exit 0. Okay, path dot push back node. Okay, path dot push back node. If I, okay, because here is the place where my path is starting. Okay, push back this current node, and if visited node, if I have visited this node before, then auto it find path begin to end node, this current node, cout end minus it. Okay, okay, shit, that makes sense, that makes sense, that makes sense. Find the occurrence where I did find this node. Okay, and then the size would be end minus this iterator, because this is the first time that I saw this, and then auto, I have found this thing. So auto cycle equals vector int create a new vector starting from it till path end, and then see out everything in that. Okay, that is elegant, that is elegant, and you do not even have to make this thing 0. That is very elegant. You do not even have to empty your path. You can use the same path vector again and again. Why? Because if they are connected, then they are in a, and then if they are connected, then they are in the wait, find. Find is linear search. So you do pop the thing back. Okay. Visited node, make this a visited node. And for next node in this graph, if next node isn't equal to parent, we also have parent. Makes sense. That is how you are keeping track of the thing. Okay, if next node is not equal to parent, then cycle search next node. If the node is not equal to parent, then cycle search this new node, add it to the path, pop from the path, and yes, that makes sense. I only add and pop. So that is cool. That is cool. This is also cool. This thing, parent, you are using parent. If this is not equal to parent, then cycle search. Okay, let's implement this thing. We can, we can of course remove all of this. Path is a vector in our case, and we have visited. Okay, let's call this cycle search. Okay, we will do the same thing, exact same thing, and this won't return anything. Or find cycle. Find cycle. It's starting here, and parent, would I need parent? Can I do if it is not equal to its parent, then yes, I cannot go to the second last thing in the path because that might be there might be nothing there. Okay, the parent is fine. Parent is fine, and in here, if visited, if I have already visited I, then if I have already visited I, then it is cool. Then I have a full thing. But I can simply, first of all, push back I. If I have visited I and I is not the parent of something, then I do have myself a solution. And if I do have a solution, then I would like to print out that solution. So auto id equals find path dot begin path dot end. And what am I looking for? I am looking for I. Find the first occurrence of I. And when I do find it, cout path dot end minus it, and then a new line, and then for while it is not equal to path dot end cout go to ip new line, not new line, space new line. If this thing has been visited before, that is the case, then do all of this. If it has been visited, this would be the answer. And if it hasn't been visited, then for int x in, I need the graph. Vector vi graph, and I should not do this. Graph dot assign n vi, right? And here graph I, and if visited, that does not matter. But the only thing I have to make sure is x isn't equal to parent. If x is not equal to parent, then DFS, then call DFS, then call find cycle with x, and parent is going to be I, because I got to x through I. Path dot pop pop back. Add this element. Has this been achieved before? If not, then add all of these elements, go down these paths, and then when you come back, remove this element. And also here, exit with exit code 0, and if I do not exit, impossible. See, segmentation fault, that wasn't expected, and of course, for int I equals 1 I list. Of course, yes. I less than n, less than n, equal to n, and if not visited I, then Find cycle with I. Parent is 0 because 0 is 0. No one goes to 0. Seg fault if not visited I. I'm call I am somehow calling the same thing again and again, which is bad. Okay, I came to I from parent. I also have access to the parent. Okay, and then pushback I. This is the place where I am at currently. And if I have visited this thing before, then shit. Visited I equals true, and it keeps on running. Oh shit. It keeps on running. That is bad. Visited I, put visited I equals true because that is where I am at currently. Visited in this, return output exit, finish the whole thing. Path begin to end, find x, find I starts from 1 and somehow keeps running. Find cycle for x and I. X and I, x is the node that I'm getting to and I is the node where I am at. Path dot pop back, remove the last thing. If x isn't equal to parent, yes, if x is not equal to parent. So what is wrong here? I do not see. Es kann nicht sehen, was ist kaputt here. Okay, I taken N, M, and all of that is cool. It was working before when I applied DFS in my own manner. If not visited I, where I starts from N, goes up till N, is not visited, then find cycle and say that cycle parent of I thing is 0. And then here, if visited I, add this to the path. If visited I, auto IT equals find path. Okay, that would work. Everything would work there. But then visited I, put visited I equals true and go through everything that is connected to I. Yeah, I do not want to print debug. I should be able to see what is wrong. Okay, if I am a good programmer, I should be able to see it. For int ix, I am going through everything that is connected to I, every node that is connected to I. And if this node that is connected to I is not I parent, that is, I didn't get to I through this node, then call find cycle with this thing. Okay. I guess I'm not a good programmer. Where is the question? The question is here, but the input, test input, this thing. Okay, segmentation fault. Yes. Okay, I go one. I go one. But why do I keep calling one again and again and again? Why am I? Yes, it is simply one. I'm just calling the function for array one again. Find cycle for x and I. Find cycle x and I. Why am I calling this find cycle function with one again and again? For x in graph I that is one should not be connected to itself. It is like wrong, right? It is wrong. Therefore, see out for auto graph see out x. Blind or slash out and it says impossible, which is fine, which is cool. One is connected to 3, 2, and 5. 2 is connected to 1 and 4. Okay, so 2 is connected to 1 and 1 is connected to 2. 2 is connected to 1. 1 is connected to 2. But that should not cause a problem. And certainly I should not be calling the function on 1 again and again. I equals 1, I less than n. Call this on I if I hasn't been visited. All right. The cyclic calls are being made from here. 1 pushback 1 onto the path. Is it visited? Nope, initially it is not visited. Then go here and put 1 visited equals true. Parent of 1 is 0. Parent of 1 is 0. And for 1 I see x. Let's say it is 2 or something. X initially would be 3. So 3 is not equal to parent of 1, which is 0. No, so call this with 3 and 1 inside 3 and 1. I go there and I see that 3, 1, 2, 3, it is connected to 1. Right. 3 hasn't been visited. So we go there and we put visited I 3 equals true. And if not parent, x is not equal to parent. X is 1, parent is 1. Right. That is messed up. That is a bit messed up. Not slash out, run this thing, copy. I do have a lot of ones. Shit. My path is full. This shouldn't be happening. Visited I equals true. Visited I equals true. Are they talking to the same visit? No, shit. That is correct. That is correct. Shit. I thought yes, initially everything is false. Okay, let's print visited. Visited is also one. I don't know how to scroll up the terminal. Graph problems are very hard. Yes, and we should practice. But this one, shit, I just solved this problem using my own custom implementation. Now I'm trying to implement the thing that was in the analysis part of CSES, this thing, analysis part, and this should not give me this much trouble. Visited I equals true. Visited I equals true. If I, okay, say that I have visited this thing before, and if I, okay, and then how am I going? Parent and I. I does start at 1. Path dot pushback. Wait, is okay. I think it is because of this thing. Shit. Go to IT. Ah, shit. Okay, okay, okay. Shit. It is because of this thing. Shit. Because I'm not incrementing it. If it was because of this thing, then it would be very stupid. Shit. Where I output it, entered the wrong input. This is the correct input. Okay, so shit. That was the thing. That was the thing. Okay, shit. Okay. Now it is wrong. Now it is correct. Now it is correct. From 1 go to 3, then go to 5, then go back to 1. I was getting error here because if iterator is not equal to path end, keep printing out the iterator, but I was not incrementing the iterator. So it just stays there and it is never equal to path end. That is very bad. That is very bad. Shit. Now submit. Round trip C++20. And what does it say? That is fine. That is cool. Now monsters. The next things. And before moving forward, what was the thing in this question? In this question, I had to find a cycle. And what am I doing exactly? I did two implementations. First, which was given to us by the analysis and first, and then the other one before that, I did my own implementations. Okay, in my implementation, I had a vector called path, which is a vector, and at ith position, you would have the index of, let's say, j, and that means you got 2i from the jth node, and you have it filled for all of the nodes. Then you have a visited vector of Boolean, which is either 0 or 1 for the whole thing. Initially, everything here is 0 and everything here is also 0. And then I have my adjacency list for node 1. It contains a vector of its own which says that node 1 is connected to 2, 3, 5, whatever, and same for everything. Then I am iterating through each node individually and I check, is this node visited before? If this node has not been visited, then I call my DFS function on this node. And I was doing something bad, okay. And if there is a circular path from in this component somewhere, then my DFS would return a pair of integers in which I would have some index here. Let's call it j. This is what is it? And this is j and I. And this means that j and I are first connected to each other. The node number j and node number I is connected to each other, and they are also connected to some other node in common. So after that, when I have j and I have I, when I have both of these things, j and I, this is my ith node, this is my jth node. When I have this, I trace back the path of this jth node to the root, and root is defined by, and for this I'm using the path vector, and this search ends when the parent of this node is equal to itself. That is, at that point I know that this is a root, so I can end. And while I was doing this, I added all of these nodes into a set, so that when I'm going back through this thing, when I'm retracing my path through this node, whenever I see that something is common, I can stop my research or thing. And while I was going back through this thing, I added all of these nodes here into a vector, and when I come out, my ith pointer is now pointing to this node that is common. And now I already know where my jth thing is. I start iterating from this thing, and I add all of these things into another separate vector. Put this here, put this thing here, put this thing here, and finally put this thing here. And how do I know when to stop? Because I know the node that is common. And now I have these two vectors, this one and this one. And what I do is I append the reverse of this vector at the end of this. That is, I take this thing, I add it here, take this thing, add it here, take this node, add it here, and take this node, add it here, and then I just print out this whole vector and I print this thing again. And this thing is the first thing that goes into this thing. So that is my implementation. But the implementation that they used is much more elegant. They have a single path thing, path variable, and a single visited vector, and both are initially equal to 0. And then they have the nodes and they are iterating through I equals 1 till I less than equals to n, the number of nodes. And they are calling find cycle, some cycle function with I, where the first argument parameter is going to be the node that has not been visited yet, and the second one is going to be the parent, that is from where I got to this node. And in this cycle function, the first thing you do is you add this ith node to the path. So path gets I appended to its end, and then you check if visited, if I have visited I before, if I have visited I before, then I know I have a cycle, right? If I have visited I before, then at some point I had in my path this ith node and then a bunch of nodes, and now I have already added the ith node. So if I have visited this ith node before, I call a find function and store its value into an iterator. I call this find function on the path and I am looking for I. This find function will go through the path and give me the first instance when I see this ith thing which I have passed down here. And then I will have the address for this thing, and the size of this whole path would be equal to the end minus this it iterator, that would give me the length, and then I can just start printing all of these things throughout the path. And that would be my cycle, which is here, find it, cout, end minus iterator, and move on till iterator is not equal to the end, and print out everything at the end, print out a new line, and exit. But if I haven't visited this ith node before, then I put visited I equals true, and I start to iterate through all the nodes, let's call them X, which are connected to I. And when I go to X, I check if X is not equal to the parent of I. If that is true, that is, I didn't get to I through X. If that is true, then I can go to X and call the find cycle function on X. And that is how we do. That is what is the solution provided to us in the analysis part of that function. Now, monsters. How many questions have I done? I have done, shit, only 2 questions. That is horrible. Only 2 questions. Okay, I want to do at least 5. You and some monsters are in a labyrinth. When taking a step to some direction in the labyrinth, each monster may simultaneously take one as well. When taking a step to some direction in the labyrinth, each monster may simultaneously take one as well. Your goal is to reach one of the boundary squares without ever sharing a square with a monster. Okay, your task is to find out if your goal is possible, and if it is, print a path that you can follow. Okay, that is BFS. BFS. I need to find the longest path. Yep, and how many diversions I went through. No, BFS? DFS would be nice. DFS would be nice whenever I am at a current node. If that node is connected to, let's say, 5 other nodes, then I lose 4 paths. But if there is a cycle, then I messed up. The task is to find, okay, path, if that is possible. The first, yep. If there is a cycle, then things would be messed up. Things would be messed up. Are there cycles in this? I guess there are. The first input line has 2 integers, n and m, the height and width of the map. After this, there are n lines and n lines of m characters describing the map. Okay, delta. Each character is a floor, wall, start, or monster. There's exactly one A in the input, but multiple monsters. Even some monsters are in labyrinth. When taking a step to some direction in the labyrinth, each monster may simultaneously take one as well. Take one step as well. Your goal is to reach one of the boundaries without you're sharing a square with the monster. That would be if I can reach one of the walls, if there is a path that goes to the wall without ever meeting a monster. Like in this case, I can go here, 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 here. But if this thing was open, like if there is a cycle and the other end of that cycle reaches one of the walls, let's say I start here and the monster starts here. This is one of the place we can go to, one of the nodes. This is one of the nodes, one of the nodes, one of the nodes, and there are walls everywhere. Yep. And yeah, let's say this is the final square. If this is the final square, let's say monster goes here, I go here. Monster goes here, I go back. Monster goes here, I go here. Monster goes here, comes here. Monster comes here, then I go here. Now I am closer a bit. Monster goes here, I go here. Now I would like to go here, but the monster goes there. And if monster is there and I move one far. Okay, I am initially here, then I, let's say, go here, then the monster goes here. When I'm here, I want to go there and die. Can Who is making the first move? No, I should not go beside the monster. Yes, makes sense. So the monster next either goes here or here. If he goes here, then I should go here, and this would never end. This would never end. If one of the monsters can reach the end before me, okay, I can run DFS. I should run BFS on the monsters. Each monster find their, no, find all the paths that shit. Okay, graph problems are a bit hard. Okay, I can. Okay, there will be a bunch of paths that I could take to reach the end. There will be a bunch of paths that I could take to reach the end. And if that endpoint could be reached by a monster before me, then that is bad. Then I cannot take that. Okay. Okay. Then I cannot take that. That makes sense. So do I need to find, okay, I do need to find all the paths that could be taken by A to reach some point, to reach one of the endpoints. And if one of the monsters can reach that endpoint faster than A, then it is messed up. So after finding all the paths, how do I see if a monster cannot reach that path before A? That would be, do I do have to go through all the monsters, but if I should I apply all the paths that a monster would take to get to the end? That would be like applying a lot of DFS. Okay, it is not big. It is not big. N is only 1000. So for every monster, I can do this thing. And at the end, I output characters. Okay. Okay. Cool. Cool, cool, cool. Okay, cool. We can probably do this one. What are you planning for? I am planning for this question. Monsters in CSES, graph algorithms. That might be too small. Graph algorithms, CSPS. There you go. N, M, and then okay. Then vector, vector, vector of strings called grid, and the size is going to be n and empty string, and for int I equals 0, I less than n, I plus plus, right? Because n rows, cn grid I, take input into the grid I, and delta tuple int char, a vector of tuple int, yeah, shit. Vector of tuple int char called delta, which is going to contain a few things. -1, this represents all the positions that I could take when I am at a given graph. If I go, this should be right. This should be right. This is right. And 1, 0, that is down. And then 0, -1, that is left. And -1, 0, that is up. Okay. And cool, cool. After this, I would like to go through and find A call it start, and a vector of pair monsters. And now for int I equals 0, I less than n, I plus plus, and for int j equals 0, j less than m, j plus plus, if grade I, j equals a, then then start dot first equals I and start dot second equals j, else if grade I, j equals m. Okay, I don't need this. Then monsters dot push back I comma j. Makes sense. My laptop phone is out of battery. Am I still visible though? Now it is not. I have no idea what any of this is, but I'm happy to be here. Thank you. Winter is coming. Shit. Okay. Now it is better. Cool. Okay. Now I have location for all the monsters, my start location, and now I need to find all the paths which I could take, or I do not need to find the whole path. I need to see the endpoint. If I can reach one of the endpoints, I only need to find all of the endpoints that I could reach from my position, and also how many steps it takes to reach that specific endpoint. And if that endpoint is the correct endpoint, then I would also need to know how I got there, the path. Shit. And I could be overlapping between paths. Okay. Therefore, when I reach an endpoint, do I right there see if one of the monsters shit, fuck, I can flip this whole thing around. Instead, shit, okay. This is cool. This is shit. Okay, this is very good. I have my grid like this. I have my grid like this. Mhm. I have my grid like this, and the locations through which I could get out is something like this. This dot here. These are, in this case, there are only two endpoints that I could use to get out. This one and this one. Now, I can do BFS on these points, on these endpoints, and see, can a monster reach this endpoint faster than me? And if a monster can reach this endpoint faster than me, then I cannot go to that end. This is amazing. Shit. This is so cool. This is so cool. And all of these endpoints are on the edge, on the battery edge. So for I equals 0, I will go through every j and check if there is an endpoint. Then do the same thing for here. And then for I equals j equals this and this. Okay. For I equals 0, go through all of the j's. For I equals 1, only go j equals 1 and the last one. How do I figure that out? is only go in the in between values if I equals 0 or I equals n minus 1 or j equals 0 or j equals m minus 1. I think this should work. So this was this is pretty cool that I can find all of the end positions and apply some BFS and see if I can if a monster can reach this position faster than me or I can. If I can, then I win, and if a monster can, then the monster wins. Now, vector pair int and exits. Now, if grid I grid j equals a position endpoint, then exits dot push back shit my bad push shit, push back I comma j. And now that we have all of the end positions, we can apply BFS on all of these, and a BFS would be a bit modified. This is actually fucking cool. Shit, this is cool. This is my delta, and this is wrong. I would now like to switch this because I am using this path. I would have to put this in reverse order. So if I move up, if I move to the right, that is j plus 1, then when I'm traversing through the other side from the my perspective, like from A's perspective, then I must have moved left. Yes, I must have moved left. And if I go one down, I must have moved up. If we go one left, then A must have moved one right. And up is down. As above, so below. Okay, cool. And now the DFS thing, which will not do anything. BFS, or much cooler name, is monster, is safe. It's safe, very cute thing to say. And int I, int j, and also the grid vector vi grid and a reference to the grid, not a copy. Copy is bad. You should not call the copy. And now for auto x in exits, call BFS or is safe on x dot first and x dot second and the grid. No matching function call is bad. Why? Grid is wrong. Grid is wrong. It is string. Now it is cool. And if I do not exit in that BFS function, cout impossible. Impossible. Yep. Okay. And when it is impossible, then it is impossible. Now, if this is some place I would like to make a move. And for this, I need a queue of queue of pairs. Q of pairs, Q, and visited vector of vector of bool visited psi psi thousand vector bool psi is thousand. And what else would I need? This one is path, path, path. Shit, okay. Vector of character path, right? Yep. Vector path, and instead of hard coding thousand, const in n equals 1001, 1001, n n shit. Okay, that was bad. n n okay, and vector of characters n. Go back. CIW n. Okay, and initially every character equals 0. That makes sense. Now is safe. Yes, q dot push I comma j, push this and visited I j equals to true. Visited I j equals true, and while not empty, while not q dot empty get auto x comma y, let's say, equals q dot front and q dot pop. Okay, now I have the address of in the grid wherever I am at, and now I need to see, have I visited this thing before? Yes. If visited, uh, okay, now I am traversing from this place to some other place, and if visited, then break. All right, do not go there. Do not go there. Otherwise, if not, and I think it is always visited, and it will always be visited. So that is bad. And if this thing, okay, but if what if the monster and I am at equal distance? Even if we are at equal distance, then I need to decide if we are at equal distance. If we are at equal distance, then also it is wrong. Then also I will be messed up. Then also I will be messed up. How do I keep track of distance? How do I keep track of distance? That is something, right? Or do I just do the DFS and yep, do DFS, and whenever I see myself like A or a monster, I stop. Yes, I could do DFS. I could do DFS. And whenever I see a monster or something else, I stop at that distance. But where do I keep the state? All of that data. Or how do I keep the state? Shortest. This would be cool, but this would mess up. What if this A and monster are at equal distance, and just by chance I happened to reach A first and I didn't got to reach monster. So I cannot be very happy because there is a monster at the end of it. Okay, what's your current rating? It is 1300, unfortunately, just 1300. But in today's contest, I hope I will reach specialist. Okay, I need to keep state. State. Given one of the endpoints, I need to see. Yes, given one of the endpoints, okay, BFS is good, but yeah, the same problem. What if A and M are equal distance apart? If they are at equal distance apart and I just happened to go to A first, then it is bad. So I can do DFS. I can do DFS. I can do DFS. Or I can do BFS like I am doing, but I will stop whenever I see something. No, no, no. Because I do not want to do DFS because it might be that I might be doing a lot of things. I, but how bad can DFS be in a 1000 block? Yeah, DFS can be very bad. DFS can be very, very bad. I could like go through everything and not find it. Shit, yes. DFS could be very bad. DFS could be very bad. So I should instead use BFS and or wait, when I am on a path to reach this point, I must go to this point, and for this point, I must go to this point. For this point, I must go to this point and there. And while I am on that path, if I encounter A first, then cool. If M first, then wrong. And this is DFS. Let's go with DFS. It is simpler. DFS. If I apply DFS here, then it will be cool. My second year just ended. I am in my third year now. Yep. It would be cool actually if we could apply DFS. The only problem that I'm thinking of while applying DFS is the time complexity, but it is only 1000. So let's go with DFS. And now visited, I don't need the queue. Right. It will return bool. And now check if visited. I could just keep going down in a loop, right? Loop is bad. Loop is bad. I would not like to go into the loop. If I have visited this thing before, what about loops? If I have visited this thing, no, if I do DFS, I need to know how far away things are, right? Level, okay. Level, level. Here, level is 0 initial, and here, if visited, I, j, return not true, mm, false. That is, do not pursue this thing any further. Return false. Else, visited I, j equals true, but this is also bad because I would have to rewrite my visited every time that I call this thing visited. Uh, put all of them equal to back to 0. So I should use a better bit set, a vector of bit set. Bit set size n called visited. Size n initially 0. Everything is 0 initially. Cool. And void put visited 0. It will go through the bit set and put everything equal to 0. So for int I equals 0, I less than n I plus plus, and bit set and equal, just take it and okay, yeah, what is the bit set, right? Yeah, visited I and equals 0. That is cool. And put visited 0, and here we are back to this thing. And before moving forward, I would like to go to the washroom. I'll be right back. Which here, let's meet at stream 3:30. Yes. Hopefully I will reach expert and or similar level. That is 180 days from today. Okay, stream 180. Okay. Stream 140. Okay, let's do that. Let's see. You do your target. You will reach expert, and I will reach expert today. This is cool. Give targets to each other. Giving targets to each other is cool. And I will be right back. Let me just go to the washroom. I'll be right back. 180 days. Yo, me back. Okay, but 180 days is a very long time. 180 days is 6 months. And you are saying in 180 days you will reach specialist. I think you can do it faster because 6 months is a very long time. And it depends on how much work you are putting in. But yeah, you can do it. Visited I. Visited I. Safe. If not visited, then true. And if visited, then true. And I would also need distance. Okay, level, level. Okay, a set of monsters and A. Okay, int A equals int max and int M equals int max and do the same thing before this, right? And then check if A smaller than M, then but where is A? If A is smaller, then where is A? And I would also have to rewrite the path thing. Instead of writing, whenever I do see that there is a possible way, I would just apply DFS once more and find the path for this A, right? Yep, DFS or BFS. And yep, DFS is nice. DFS is nice. No, this is bad. Okay. I can write two BFS functions instead, or a single BFS. Okay, this whole thing is wrong. This whole thing is wrong. This whole thing is wrong. Instead, I should write a function which gives me two things. Index, which gives me two things. Path, nope, no, not the path, which gives me two things. Only one thing would work. Integer, find distance, starting from int ij in this vector of strings called grid, find distance for this char C, right? And this is going to be BFS. Q pair in Q. And this is not visited. And visited I, j equals true. And Q dot push I, j. And while not Q dot empty, while Q is not empty, get this thing auto x comma y equals Q dot print and Q dot pop. And now if grid x y equals c, then I have whatever I needed. and return. Shit. I also need distance. I also need distance. Ah, shit. Okay, this is bad. This is bad. I also need the distance to this thing. This is going to take a lot of memory writing, rewriting, writing, and rewriting. Oh, yep. Or I do not have to rewrite. I can initialize new thing and use new memory. Vector of vector of integers and path, not path, distance and distance if this equals this thing. Distance for this thing would be distance I initially j equals 0. Okay, distance is ambiguous due to some reason. And size is going to be capital N and I capital N. Okay, now I have distance and visited, and if this is correct, then return distance for x, y, or distance CE to E. Else, if this is not, then see if it is visited. Then go through. Yeah, yeah, it is visited. Then go through. For yes, now is the cool thing. Now is the cool thing. For dx, dy, and dx, dy, and ch. No, I do not need the character right now. Okay, I have to change my delta. This is going to be called delta with characters, and I need another one, normal delta without characters, which can be pairs. Okay, now I inside this thing I will iterate through this. Okay, I have dx twice, make this y, and with this changes through my with these dx and dy changes to my x and y coordinates, int nx new x ny comma ny, nx equals x plus dx. Laptop is also running out of battery. Ny equals y plus dy. Now, if nx greater than equal to 0 and nx less than grid dot size, and same thing for y, if ny greater than equal to 0 and ny less than grid 0 dot size, that is I can cool. Yeah. Shit. Okay, okay, it will work, it will work, it will work. And if it is not a wall, if grid nx ny isn't equal to hash, and if not visited nx ny and wall is not like this, then wait. First of all, I have to plug in my laptop. My phone is sufficiently charged, but then I need layering system. Distance. Yes, I can find the distance from there, right? I can find the distance from the distance grid, distance matrix. And yes, actually, shit. Yesterday I was reading a book, and there it was said that instead of using a vector of vectors to represent a matrix, it is much better to use a data type that is literally called matrix. Yes, matrix. Matrix. Hmm. I guess it is some custom library then. Yeah. If not visited and it is not this thing, then distance for nx ny equals distance for current x current y plus 1. Put the distance and visited x y equals true, distance for x y equals true, and what else do I have to do? And push it into the queue. Q dot push n x comma nx comma ny, and I do see my mistake, which is this has to be n x and ny. Okay, this is going to be very, very horrible. Yep. What if I never find the thing? If I never find the thing, then the distance is going to be infinite. Return int max. Otherwise, if I do find the thing, then this. Okay, so this function push back, if not empty, find, get the current things, and if the current character I am at, if it is equal to the character that I am looking for, then return the distance to this current character. Yes. Otherwise, iterate through all the things that I to all iterate to all the places that I could go to, and then new x and new y. New x is x plus delta x, and new y is x plus delta y, and are new x and new y in the correct range? And if they are, check. If I haven't visited those new x's and new y's and they are not a part of the grid, they are not evolved, then distance to get to that thing is going to be distance of the current place plus 1, and visited true since I'm going there, and push it onto the queue. That is DFS, that is BFS, that is BFS, and this function should give me the distance to A and M, right? And I will do this for all of them. A and M is safe. What the heck is safe? I am using now is find distance. Put 0 visited. Yes. Find distance to from I from x dot first and x dot second, and what else is needed? What else is needed? Okay, I went to the wrong function. Yep. What else is needed? The vector, grid, and the character that I am looking for. Okay. Grid and the character I am looking for. Let's say it is A first. A, yes. A is this. I don't even need to do this. If find, okay, let's make this a little bit more readable. Find distance x dot first and x dot second, and grid, look for A in this thing, and int M monster, find distance, replace M and replace with M, and if A is smaller than M, then cool. If A is smaller than M, then cool. Let's say cout yo, and bool then equals false, and if this is the thing, then equals true, and break. Okay, makes sense. At least I should see you and info if not done. I should see you, and I do see you. So that's correct. Instead of you, I could just say yes. So the yes part is correct, and now I do know that I do have an answer. What I have to, okay, let's even see if what these values are. Okay, and for M, I never reach a monster from this path, which is messed up. Okay, let's say I do not break. So I'll do this for all of them. And 6 and 7. So in that I say 5, right? So 1, 2, 3, 4, 5. 5 is cool. And here I'm saying 6. 1, 2, 3, 4, 5, 6. But why is monster 7? Monster should be 1. Okay, why am I mixing up with the monster? Because I didn't rewrite path. Because I didn't rewrite path. Okay, right. Put visited 0. No, no, no. This shouldn't have been this complicated, but let's say it is this complicated. Now I need to do n square, 10 power 6, and put everything equal to 0. Uh, okay, is that why they gave me? They only gave me 1 second. That is going to be wrong. Shit, that is not going to work. Shit, I am not a complete beginner. I am pupil, so 6 months would be good, I guess. By the way, I am 45th year. I am 45th year now. Shit, you are 45 years old, Captain. I'm not regularly showing up recently. I am not done uh, good in QAs, OAs. So I was very disappointed with myself and weakness. So I decided uh, to put my all for the next 6 months. Here I also said expert or similar level. What I mean is lead code guardian rank equals E. Okay, I do not know about lead code ranks. I might be wrong here, but I will assume that is cool. Just grind, Mr. Captain. You are 45 years old. Just grind. Okay, 45 years old. 45 years is that you are more than twice as old as I am. Just grind. Want to ask how to build logic and intuition to solve with what's your mental workflow of thoughts. I mean, it is hard to describe, but that is what I try to do. But I do not think most of the things that I say are comprehensible in the sense that I'm not very clear when I am solving very my questions and I'm not clearly explaining what I'm doing. So that is bad. But you can develop your intuition doing this thing. This is what I did, and this helped me a lot in generating mental connections for solving problem solving. So that is good. It is the same name as my channel, my name. I don't personally unless you enjoy competitive programming, I don't see the point in proving to others that you can be great at competitive programming. It doesn't prove that you are smart, only that you are hardworking. That is what I'm trying to prove. I'm not trying to prove that I'm smart. I'm just trying to prove if you work hard, then you can reach whatever you want. If you don't personally find competitive programming meaningful, it would be as meaningless as making the biggest rubber band bell in the world. But okay, so I have to do something great in my life, but I do not find passion and meaning in a lot of things. So whatever great thing I have to do would have to be something in which I do not find interest in. So if I can train myself to grind hard in things that I do not like, then I would be able to do a lot of things, right? And it would not be as meaningless making the biggest rubber band ball in the world. I mean, it is also hard, right? You cannot do it. I can challenge you. Sanders Lin, you cannot make the biggest rubber band ball in the world. And if you can, it would be pretty cool. You would be hardworking. Fourth year. Oh, shit. I got scared. Typo, lol. Shit. That is cool. Then, Captain, we are comrades then. Comrades. Okay, lost my track of thought. Yes, restart. I have to write some function which will restart everything, which is n square time complexity, and I do not like it. What would be better? I guess assigning path dot assign n and the same thing here. The same thing, right? But this is also bad. Yep. Instead, yeah, shit. I equals 0, I less than n I plus plus. For j equals 0, j less than n and j plus plus path I j equals 0. Restart. Okay, nothing changes. Shit. Nothing changes. I'm getting the correct value for A, but not for M due to some reason. Find distance, the shortest distance starting from this thing to A, and find the shortest distance to M starting from this x first and x second. Somehow it comes out to be wrong. Okay, what are the things that I'm using here? I'm using this. Okay, okay. Shit, my bad. Uh, shit. And monsters. All right. And I can take this above. Okay, and full distance I make every distance equal to 0. If grid equals to the character that I'm looking for and return, okay, it is still returning the wrong thing and it is only messing up. Shit, makes sense because I have to restart again. Yep, yep, that is cool. That is better. Okay, what? A is 1 and M is 0. 0, I guess, because I start here. But why is A equal to 1? Did I start from this point? If I equals 0 or I equals n minus 1, then go. Or if none of those, if I'm in the middle for I, then see if j equals 0 or j equals to the last one. If that is, and I see a dot exists, push back. For auto x exits, see out x dot first speed x dot second. Okay, jump to definition. That is cool. A harpoon is cool. 3 and 7, 4 and 1, 3 and 7, 4. Huh? 7 is cool. Okay, 3 and 7 is cool. And 4 and 1 is also cool. 4 and 1 is also cool. Yep, 3 and 7 and 4 and 1 all are cool. And for 4 and 1, why do I say that to get to A, it would take me one block? and to get to M, it would take me 0 blocks somehow. A and M. Laptop is charging and it's been 3 hours and 16 minutes. I haven't even done 3 questions. Shit. Okay, at least I will do this one. Shortest route. Should this might this okay, I will do this question on my own, but the thing might be that it might be using some of the algorithms that I haven't read about. It is not because I'm stupid. It might be because I haven't read about these things. It might be using one of these algorithms. The main goal is finding the exit points is easy. It takes n square time and n is not very big. N is only 1000. So n square is just 1e6. So that is cool. We can do that. And after finding those points, the main goal is to find the closest monster and closest A. And then I can just apply BFS for that, which I am applying. But the thing is, while I'm doing that, I need to keep track of the distance which takes state and maintaining this much state because I have to rewrite the state every time that I do another BFS. I'm doing a lot of BFS. Yep, I'm doing a lot of BFS. And even then, it is not working. Even then, it is not working. Even then, I am getting the wrong answer. Here in my BFS, I'm getting the wrong answer. Look for C. C, the character that I'm looking for. Push back I, J, my starting end points. Distance for this thing is 0. 0 is wrong. Why would I ever? Distance. Yes, distance. Last distance. And I'm making distance equal to 0 for everything. Okay, a distance is one thing that I'm using here, which I am putting back to 0, reinitializing in some sense. And I am also putting visited equal to 0 for everything. And grid, I'm not changing the, yes, I'm not changing the grid. Q is empty. Q is empty. Or maybe fucking not. Q is not shit. Shit. Okay. Shit. Q was not empty. Q was not empty. Q was not empty. My bad. Q was not empty. Now it should be better. Okay, 5, 6, 5, and 6 to get to this one. Cool. And 6 to get to A, and 1. One step is this, and 6. Okay, that is cool. That is now working. Now, if I ever see here, if I ever come here, then I can run DFS or BFS, does not matter. Just get the way. I think I should run DFS, and I will need to find the path that I took to get to that point, for which I can use the same thing. I can use the same thing which was in this roundabout trip, in which they had a single path string, right? Path vector, but we would use a string. String would be cool because we need to add, we are working with characters, not with anything else. That is cool. This is the thing. Then and that function will return, because I know for a fact that I can reach the end with this, so I don't need path, like I do not need to retrace anything. By the way, this thing is actually cool. No, a round trip. Yep. Building teams, and yeah, building teams was about bipartite graphs, and a round trip is about identifying a circle. This thing is actually cool. The method that they are using to find the path, not to find the path, but to store the path, in which they push back this current node, run everything with that node, and then pop back. This is cool. This is cool. You can do that. A string path initially empty, and now function will return a string find path starting from int ij. I'm looking for a, I know that, and vector of strings grid. And yes, I am very stupid here. Wait, it is much better, much better to use a reference here. Okay, now here I am, and I add to my path this thing, and I'm going the opposite way, right? I am going from the opposite way. So I can use my delta with characters. If I have reached, if grid I j equals a, then return paths. Okay, else I also need another visited shit. Yep. Else visited is going to be true. Else path dot push back. What do I push back? I don't push back. At least not here. And then I will go through for auto dx dy and c in delta c. Can I do this? I can do this. This is cool. Okay, and then int ny nx is going to be x plus dx, and int new y is going to be y plus dy. But what are x and y? Yes, that is a good question. This is so bad. Uh, I okay, nj, right. I can reach this thing. And now, if they are in range, if ni greater than equal to 0 and ni less than grid dot size and ji greater than equal to 0 and ji less than grid 0 dot size, right? If this move is legal, and then if grid ni and nj is not equal, okay, if it is a monster, then do not go there. If it is not equal to m and grid ni and nj, this is pruning, I guess, in some sense, is not equal to end, is not equal to a wall, and also not related. Okay, yeah. Okay, what is NJ? Yeah, makes sense. What NJ? C is nothing. C senior. Size cool. Grid Ni, grid Nj, if that is not equal to M, I am not face to face with the monster and I am not face to face with the wall. And I have not visited this thing before. And visited IJ, not visited IJ, then it would be actually cool to go there. So path dot push back C. Shit. Yes. Okay. Path dot push back C. Find path Nij was in the grid. Shit. Okay. Okay. And I will capture its value. String NW. There is going to be a lot of strings. Shit. There is going to be a lot of strings. Shit. Shit. String SW. Yeah, time complexity is the thing that is scaring me in this question. Yo, VF this delete, go to the end, paste. Yep. If NW is not equal to empty string is 0. If NW, then return NW. is not is not equal to empty string. If if NW is not equal to empty string, then return NW, and at the end return empty string. Okay, my bad. Also, yes, visited Ni Nj equals true. Visited is true. That is, I have visited, and path dot pop back. Seems like that will work, but let's see. Path dot pop back. Path dot pop back. Okay, visited true. Path pop back. Yep, and if nothing, return empty string. Let's go. Okay. Before this, restart and string p equals find paths int I. Why am I writing I? I x dot first and x dot second and grid on this grid and reverse p dot begin and p dot end. See out p. Okay, this is going to be crazy, but before this C out P dot size. Do I have everything that I need? I do have everything. Feels like R T R. Yes, feels like I do have everything and cool. Segmentation fault. Okay, segmentation fault. There's something is wrong with find path. Not find distance, but find path. If it if it equals A, then cool, very very cool. Go through all the delta, di, dj, and c, and yes, iterate through delta c for auto int ni equals yes new ij, and if this new ij is in the range, which I'm checking, if this new ij is in the range ni greater than equal to 0, ni less than grid dot size, and nj greater than equal to 0, and nj less than grid 0 dot size, if that is the case, and grid nj is not equal to m, I'm not at a monster, and I'm not into a wall, and that makes so much sense. So much sense. That makes so much sense. No, that does not make sense. And not visited. Yes, this is fine. And not. That does not make sense. Shit. Why did I even say that? And I and J. Okay. Then path dot pushback C. C senior string and new visited. Shit. That was it. This has to come above. I first put this in as visited and then I call the function instead of this thing. Yeah. So first visited equals. Okay. Let's see. Hmm. Hmm. Why do I even say impossible at the same time? Hmm. Hmm. Shit. That was very close. Okay. Output yes. Output yes. Output yes. Output yes. Output. Okay. That is working. That is working. So the algorithm is correct. Yes, first I'm seeing from every endpoint that I could, from every exit point, I am seeing what, who is the closest monster that I can reach through this point, right? And also, what is the closest path from this exit to A, right? And then I'm comparing both of those, both of them. And if A is shorter than M, then cool, I can do this. And if that is the case, if A is shorter at some point than M, then done equals true, restart, like reset all the path and stuff variables, then find path, P string, and I should not reverse the thing. I should reverse it when I do get it back. Right. And cool. See how it is and everything. Okay. Why is it 120 lines of code? I think this should not have been this complicated. Okay. Monsters. Let's go there. And inside monsters, submit. Choose monsters, C++20. Yep. And wrong answer, wrong answer, wrong answer, wrong answer, wrong answer, wrong answer. And time limit exceeded. Yep. Yep. Wrong answer and time limit exceeded. Shit. Like, look at this code. This is so long. Okay, I have to output no instead of saying impossible. Okay, my bad. I have to output no instead of saying impossible. Mm, okay, wrong answer for ninth. Literally a wrong answer. Okay, my bad. I was not breaking the thing. Okay, I should probably check my solution. That is so dope. Shit. Shit, I am already at the end. Shit, I am already at the end. If I'm already at the end. Yes. Shit. Shit, 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 shit. My phone is running out of battery, which is sad. But we got this. We got this one at least. When I'm looking for pairs, if I ever see grid I, grid J equals A, then it is like done. See out, yes, and see out 0. And let's call this space end, and we would go to end. Actually, literal end. Or exit 0, which is much better. Let's see. Yep, this would work for this case. And what are the other things that we are getting wrong? Something like this. Yep, this would also work in this case. Empty. Okay, let's see. Let's submit and see what the thing is. Continuity camera. Okay, time limit exceeded. Yep, that is the thing. Okay, wrong answer is something that I shouldn't be getting. Wrong answer is wrong answer is it because there are multiple ways to reach the end? Just go down. Okay, this one is more complicated. My answer. w- Why do I do this? Why do I do this? Why? Why do I do this? Okay, so BFS would be better. BFS is the thing to go when I'm looking for the path because I have to look for the shortest path. This is so retard. Shit. Go right, right, then go down, then go left, then go left, then go down 3 times, and you are at the end. Instead of going just down. Shit, that is very retard. Shit. Okay, so I will have to apply BFS. But now I would like to rest for a bit. And by rest, I mean just take a walk. And then I would get back to it because today is also a contest and it is going to be cool. Today is a contest and I would try to reach specialist. I will reach specialist today. In today's contest, I will reach specialist. I will do my best and I will reach specialist rating. And if I don't, I don't know. I want to reach specialist in today's contest, but there is also a hacking around after today for 12 hours after the end of the contest. So we would have to see. Ratings would take time to be updated, but I would get a indication as to what my rating change would be. And also, I will try to get to solve at least four questions, and get a rank of 1,000. Under 1,000 would be very cool. 3-digit rank would be very cool, actually cool. And that would be the end of today's stream. Thank you for